Good day, my name is Suri and the project we're going to present is the Hairdryer. Our lecturer's name is Incha Balarude bin Mohammed and the group members are Harun and Bharati. The introduction is Hairdryer is an electromechanical device that blows ambient or hot air over damp hair to speed the evaporation of water to dry the hair. This magical invention, which is thought to have appeared in household, is about 2020 and has been drying hairs for decades. So this project is to build a hairdryer with STM32F103 microcontroller. There are 3 inputs and 4 outputs used in this project. The problem statement is user have to buy 2 different hairdryers which are one for cold setting, another one for hot setting. So design hairdryer using chain vision, size software and proteins for software simulation. The objective is to learn about how STM32 is useful for many applications. The second is to learn the features in handling STM32 features to handle complex projects. Number 3 is the hairdryer has both function in single appliance. This appliance can make users to save their money and very convenient to carry to anywhere as there is only one appliance with both functions. So these components are the main is STM32F103, then diode, transistor 6-pin, battery, capacitor, relay, resistor and pin transistor. So the inputs are 3, there is 3 push buttons and output is 4. There are LCD display, 2 LED, DC motor and blower. The procedure is first is start, the number of push button is pressed, then LCD show device on. So the first is push button 1 is continuously pressed. If yes means LCD show low, DC motor rotate slowly and green LED light up. If no means LCD show device on. Then the push button 2 is continuously pressed. If yes means LCD show high, then DC motor rotates fastly and green LED blinks. If no means LCD show device on. Then if the push button 1 and push button 2 is continuously pressed. If yes means LCD show error. If no means LCD show device on. Then push button 3 is continuously pressed. If yes means lower temperature rises and yellow LED light up. If no means the same, then end. So next, that's all for me. The next part, my friend will discuss the reason about the coding part. Thank you.
Hello there, my name is Harun Krishnan, metric number EA18180, and for today I'll be explaining about our Proteus design and simulation for our title project, for our mini project, which is we are taken the hairdryer, and shall we go into the Proteus simulation. So as you can see here, this is our Proteus design, where we have divided them into their own segments or sections, where the push buttons represents the input, while the LED, LCD, DC motor / fan and the blower represents the output. So let's start our simulation. So when we start our simulation, it will show, the LCD will show the device is on. So what happens if we push PB1? If we press PB1, the green LED here will light up, the LCD display will show low, and the DC motor / fan will rotate slowly. This is to show that this is the lowest setting for our hairdryer. Now if we off PB1 and press PB2, the green LED light here will start to blink and the LCD display will show high, while also the DC motor / fan will be rotating much faster than the previous DC motor rotation. This is to show that PB2 represents the high setting, while PB1 represents the low setting of the hairdryer. Now what happens if we press PB1 and PB2 at the same time? The previous LED and the DC motor fan will stop working and stop its action, while the LCD display will show the error message. This is to ensure that there will be no complications while the hairdryer is operating, and to ensure that it is in a much safe condition. So let us off PB1 and PB2 and let us press PB3. Now what happens if we press PB3? So you can see just by a short amount of time, if we press PB3, the blower temperature here will start to increase. So let us continuously press PB3. The yellow LED light here will start to light up and the LCD will show device on. On our right hand side here, the blower temperature has increased to 100%. So what does the 100% mean? The 100% mean that the blower temperature has increased to its maximum value and the air which is being released is hot. While if it is 0%, it represents the cold setting. So the blower temperature, it will start from 0% and gradually increase every 25% until it reaches 100%. So it will start from 0, it will go to 25, 50, 75 to 100, and 0 means it is in the cold setting, while 100 means it is in the hot setting. So you can see here, if we stop pressing PB3, it will gradually start decreasing in temperature. So that is all from me, and I'll pass on to the next presenter who will be talking about the coding. Thank you.
Hello, my name is RP metric number EA18048, and I'll be presenting the kill coding for this project. So this is the codings, and I will this is the coding in the microvision software. So first of all, we must include STM32F10. Then we define RS and EN for the LCD, and then declare function used in the LCD. For example, void LCD command, void LCD data, void delay MS, void LCD display, and then to the main function. Here I put a string to display in array. So for character A, it represents high. For character B, it represents low. Character C for error, character D for device on. And then we enable the clock, and then set input and output for GPIO-B, GPIO-A, and GPIO-C. So for GPIO-B from pin 0 to 7, GPIO-A from pin number 13 and 15, and GPIO-A again is pin number 0, 1, and 14, 15. Sorry, 0, 1, pin number 6 and 7. So GPIO-C for output, it is pin number 13, 14, and 15. Next, we turn on the LCD for command 0x388. It's set 8-bit data mode, 2 line, 5 times 7 font. For command 0x0e, it display on cursor. For display command 0x01, clear screen, and LCD command 0x06, shift cursor right, and LCD command 0x80, cursor position 0, line 1. And then we go to the here main. So button GPIO-A IDR is input 0x0F, means pin 0 and 2. It will monitor pin 0 and 2. Then if button 1 is pressed, the LCD will display character A, which means high. And then if button 2 is pressed, the LCD will display character B, which means low. And if both buttons are pressed, the the LCD will display character C, which means error. If nothing is pressed, the LCD will display character D, which is device is on. So that's it. We close the bracket for the main coding. And here we ODR and RS means we reset the RS pin to 0, and here we set the EN pin to 1, and then we reset the EN pin to 0. Same goes here. We set RS pin to 1 and set EN pin to 1 and reset EN pin to 0. So that's all from me. Thank you.